Great. So I'm Nate Torgerson. I'm presently the Portfolio Director of Research Technology for Medtronic in the neural stimulation business, and more specifically the pain stimulation business. So that's making medical devices that help for relieving chronic pain. But I've been with Medtronic for 28 years, and I started as an electrical engineer by degree, started as a software engineer, and then 3 years later I became the first systems engineer for that division. So I've kind of worked up the scales. Was a system engineer for 20 years. They continue to see the need of system engineering, and that created a new position that they had called a chief engineer, which is then looking at kind of the systems of systems. And then
Nate, I don't think your mic's on.
It also doesn't work very well. You almost have to hold it. Yeah, you may have to hold it up or put it on your lapel.
green usually means go, but
Yeah, it's on. It just is.
okay.
It's not a very effective mic.
Okay, is that better? Okay. So they create a position called chief engineers, and our division had 4 different therapies. So we had a chief engineer at each therapy, and then we worked together in the systems of systems to try to get synergies between the products that these different therapies would create. Right now I switched over to Director of Research Technology, but that is more on the front end. So now I'm looking at the research associated to get good inputs for what type of systems we should be creating. So even though the titles have changed, I'm still in that system mentality. And I've been evolving as the businesses have evolved on how to create that system thinking. And since I'm from Medtronic, it's a big company, there's always disclosures. Okay, I am a Medtronic employee. I need to disclose that. The views of the speaker not necessarily reflect the views of Medtronic. And there's some concepts that we discuss in early development and research tools. They're investigational devices and limited by the federal law to investigational use only, so they are not on the market. So just as a background on what we do at Restorative Therapies Group or neuromodulation, as far as stimulation is concerned, there's 3 different businesses. One is the spinal cord stimulation business. They basically are pacemakers. They look like pacemakers. They have leads that go into the spinal cord area and epidural space. They provide pulses to the nerves, and that helps reduce pain. The middle one is sacral neuromodulation. That's our pelvic health business. They provide stimulation to certain nerves to help with incontinence. Then the third one here is deep brain stimulation. Same concept, leads go into the brain, and that helps relieve symptoms for Parkinson's disease and for essential tremor, and also for dystonia. That's actually quite remarkable when you see the pictures of how that transforms people. So again, you can kind of see that there's a lot of similarities between those, so we try to create products that help all 3 businesses. We also have an implantable drug pump that is used for spasticity when it's filled with baclofen, and also when it's filled with morphine, it's used for pain control. Same concept, there's a catheter that goes into the intrathecal space of the spinal cord to help with pain relief. So that's a little bit of my background. So now I need a little bit of your background. So raise of hands, how many here are a system engineer? Okay. How many of you have been a system engineer for less than 5 years? Okay. How about 5 to 10? 11 to 15? Over 15? So a very good spread. I'm glad to see that. So I'm going to cover some concepts, but there's going to be involvement from you. Talking about chaos. So what is chaos? Oh, one more question for you. How many of you have an official system engineering degree? So think of that. We have hundreds, if not thousands, of man years of experience, and none of it came from a university.
I have a philosophy degree. Does that count?
We all have good degrees, right? So that's the importance of some of the work with INCOSE, right? We are sharing our knowledge because we kind of learned this out in the wild, right? Now, obviously, there's system engineering degrees coming, but it'll be interesting to see how a pure system engineering degree works versus when we have you have an electrical engineering degree or mechanical, and then you work your way into systems, how that will work out. Okay, chaos, complete disorder and confusion. Another definition, behavior so unpredictable as to appear random, and a similar one, a state of things in which chance is supreme. So when you look at chaos in our projects, is that a little bit of a stretch? Maybe. We have a lot of difficulties we're dealing with. But I think in retrospect, when you look at them, you can find a reason why they happened. It's not completely random, but it made a better title. But what I want you to do now or during the program is either tweet or write down some chaotic situations that you've had in systems engineering. We should have time at the end, and I'd like to go through those kind of real time with you. We have a lot of experience in the room. I bet there's a lot of good input too. So if it's something that you'd rather not disclose where a company it's coming from, write it on a piece of paper and we'll send it in. If you don't care, you can tweet it. Okay, but just think about that. At the end, so after my presentation, we'll kind of collect them, especially if the presentation did not answer your questions on how to deal with some of those situations. Okay, so product development, we have our INCOSE book, and we talked about Agile a lot. So waterfall isn't always the case anymore anyway, but there's usually a flow of how we do requirements. Problem is, we get thrown into situations where that wasn't happening. And so in my description of waterfall, or description of solutions for systems, I'm not going to follow the waterfall model either, because my experience was backwards. So we're going to go up the waterfall. Now in this case, being a fish out of water for a short period is actually good, because you're working your way up. So chaotic condition number one. Let's see if any of these are recognizable to you. The request to test in quality. So you've been put on a project, you didn't start the project. Now you're on it, and it's done, and they're just having problems. They're finding issues in test. So they want you to come in and fix it. I've been in this quite a few times. So again, it's late in the project. When you investigate, there's probably a weak architecture that was causing the problem in the first place. Right? So numerous problems have already been found and supposedly fixed. So you can't really test in quality, right? But can you determine if the existing quality the system has, is it acceptable? And if not, can it be improved, or do you have to scrap it? So just a little bit of my history here. The first project I worked on in '92 was a stimulator that had external power. Here's an example of it. I wrote the code for it and was doing unit tests. And this was my aha moment in systems engineering. We did not have system engineering in our division at that point. And I think in general, system engineering was pretty young yet in the medical industry. So I was writing these unit tests. I'm like, I wasn't very confident. I mean, I was doing them and they were going to run, but I wasn't really confident that I was finding anything, because I was kind of following the same logical flow that the designer had in the first place. So I took a day and I took a step back and thought, okay, how is the patient going to use this and potentially abuse it? right? So I took it, I pulled the batteries in and out, and then in an hour I found a problem. There's these switches in the back, and there's two modes in this device, a physician mode and a patient mode. When the physician switch is selected, the switches don't do anything because they don't want the patient to, or when it's in patient mode, the switches don't do anything to change the electrodes, which the electrodes on it determine what contacts on the lead provide the stimulation. When you switch it to physician mode, those contacts do something. Well, because the integration wasn't that great, they didn't think about what happens if you switch the switches in one mode and then the mode switched. So now it actually did take those electrode settings, even though it wasn't intended to do that. So sometimes you have to, integration is usually what gets us in trouble, is not thinking about how things interact. So that was my first, I think if you're looking at how I got into systems engineering, it was that system thinking about system use testing or use cases, going back to the customer, how could they potentially mess it up? And then also I was looking at switch debounce. I created some electronics actually to debounce the switches. You know, with the electronics in it, the switches, the rise times, fall times on the electronics is a little bit different than just writing that code in a unit test. So I looked at that as well. So that was positive, and really that project went very well. There were no issues in the field, and it was out in the field probably 15 years. The next project I had, they saw the value that I brought, and they asked me to help. And I said, well, okay, I've got some ideas now from my past, because on that first project, I was a single engineer. It was very easy for me to travel, so I actually trained the sales force on that product. So I brought back some knowledge about how these devices were being used. So they wanted me to use that on this next project. So I actually delved into system design then. So there were some design parts that I was doing on that project, particularly with telemetry and how you handled air cases in telemetry, because that wasn't necessarily handled as good as it could have been on the prior product. So again, I went into design, but then also I was assigned this testing again. And I got this reputation now almost that some directors weren't going to approve a product unless I did the testing, because then they felt confident, which is not a good situation, right? You don't really want to rely on testing. You want to rely on the design and the architecture and your confidence. That's the kind of situation we're in back in the early 90s. Did a lot of system testing. One thing again was this reed switch. There's a reed switch in there that a person could put a magnet on it to turn the device on and off, but they really didn't test the electronics as far as toggling it, because if you're not careful or you shake, sometimes reed switches are a little bit fickle. They'll chatter. So I actually made an electromagnetic switching system to actually test that, and we found some mistakes in the hardware there. These were all ASIC designs back then. There weren't any microprocessors, so it was very critical to define these things, because you had several weeks of iteration on an electrical design if you found a mistake. So they finally asked me, hey, we have so many projects. You've got to tell us how you do your testing, right? It's not black magic. So I sat down and thought about it and kind of wrote it up. Basically, when I was doing this free-form testing, and again, this is testing that I don't consider you to take credit for in your quality system. Once you enter the quality system, it bogs it down. This is stuff that I encourage to be done before you do your formal testing, and very, very early. I think when you look at Agile, this is a case where you can do this stuff early. But what I looked at is the states of the system and the interrupts, basically, or what things can happen on the system. And there's a lot of random or events that can happen at any time, right? When you're dealing with devices where there's a patient that can push a button, that button can be pushed at any time and in any state. So I put a grid together. I called it the freeform interaction test matrix, where we looked at the interaction between states and events. And we assigned them, and we did some testing in that spot. This is an example of one. They can get pretty complicated, right? This isn't the biggest one we had. But basically what we would do is look at the cells. If a red issue, if there was an issue identified, we'd mark it in red. Yellow, there's an observation. Sometimes the tester didn't know for sure if it was a problem or not, but it looked weird. Green meant it was good, and gray was that there wasn't any interaction. So this was a quick way to test kind of the robustness of this. And a lot of times this would actually help, just looking at the matrix itself would help the official testing to make sure they had good coverage as well. But the whole plan of Freeform was we didn't spend a lot of time writing it down, because as you know, when you develop tests, a lot of effort goes into writing stuff down and then writing the reports. This was basically, you give them an idea, you give them training so they understand the system well enough to be able to test that cell reasonably, and then you have them run it. These cells, they can go through fairly quickly. Some of these cells might take 5 minutes to do. When you start finding issues, sometimes they can take longer, especially the follow-up with it. But you will see sort of trends like this. Like, obviously there's a feature here that had lots of problems, right? It should not even been out there. It's typical to have something like this where you might find a few. But again, we find that early, especially with Agile, and then they can solve those quickly without causing too much delay. Now, again, this is testing. The real value of this analysis is looking at the system architecture and design. So I recommend that, again, you can do it informally to begin with, but just look at all the states at the very beginning and the interactions and see how complex it is. If this matrix is huge, you might want to look to see if you can simplify it, because that stuff is going to come and get you later. One example that we had on this is we have devices that are rechargeable. So there's basically a recharging mode and a programming mode in the same device. When we did this analysis, it made more sense for us to literally switch modes when someone tried to change a parameter. Just turn the recharging off and go into programming mode. One of the designs we went through with earlier was one that you try to keep the recharging mode going at the same time. Very little value for the patient, because you weren't going to delay the recharging too much by having it by stopping it, but added a ton of complexity, because the recharging is grabbing data from the device, making decisions on it. So there's this telemetry exchange going on with the device at the same time the patient's trying to change the parameters. So it added a ton of complexity to keep both of those things running. So when you look at these grids, sometimes you can look at ways to simplify. Another case is on programmers, how often are like parameters pending? We kind of had a rule that made it simple that when you switch from one screen to the other, you want to get rid of all your pending values, because one thing, the user can't see the values anymore, but if you have these pending parameters that continue to exist as they do more and more tasks, it gets complicated. Mentally they can't even keep track of it, and then the system has to keep track of it too. So there's just a couple ideas there. Now this kind of flows in nice with some of the work in the INCOSE book. I referenced the n-squared diagram here that Dave Walton helped put together. But so again, looking at the design part, this flows into, this is more of the design area and the architecture, how different functions are going to interact with each other, and you actually write rules about it. So if you're looking at ways to save money on a project and for quality, this is a couple examples. You can do some of this fast testing at the end, but to save some cost on retesting, but then also for the quality side, get up on the design side early on with this type of mental thinking. Okay, chaotic condition number 2. Poor communication on the team. I'm sure we've all dealt with that. So there's a few reasons for it, right? Sometimes you're not centrally located. You have introverts on the team. There's language barriers. Some of the members don't get along, and you heavily rely on written documentation for understanding. I think that's one thing that I'm very nitpicky about. If you look at a risk in your system and your team, that's a big risk. So systems has a unique role that can help with this. We are basically the technical manager of a project. And it goes beyond writing good requirements. We have to, I think there's 2 keys to system engineering. One is understanding, and one is communication. The other one is communication. So understanding your customer. There's probably some of you that are maybe the only system engineer. There's some of you that probably are an engineer, a system engineer amongst a group of engineers, the system engineers. But whatever the case is, the system engineering group should understand the customer better than any of the other engineers, or probably out of need more than anything. It's hard if you have a project that has 100 engineers on it for them all to go out to the field. In fact, I say it's very risky to do that. Case in point, it's good for them. It's good for engineers to go out and see the customer, maybe a couple or so. But the risk is that they're only going to see 1 or 2. The real feedback that you need for a project is based on hundreds of customers. So there's always the risk that they're going to see a flyer. This physician or customer is going to give them an idea that's kind of off the wall and doesn't fit the rest of the models of your general customers, and then that they're going to take that and run with it. So whenever we have engineers that go out to the field, I like to follow up with them and see what they learn, and then give them some background on in general what we see in the field. But so understanding the customer, and then how is the best way to communicate that? As I show here, I was at a presentation at the American Medical Device 2017, and as far as documentation, even the FDA gets it. Let's say one device manufacturer can meet FDA requirements and still make a poor quality device, whereas a second manufacturer cannot comply with all the FDA requirements and make a high quality device. How can that happen? Well, our quality systems can look very good from an audit standpoint, but sometimes the way they're written are not conducive for information exchange for your engineers. So if you have a quality system that works well with the FDA, that's great. I wouldn't recommend changing it, but you have to take care of the other thing. How are you going to communicate to the engineers so they know what to build and why? So this is just like coaching. There's not a one-size-fits-all. You need to look at what type of team you have. Just like in basketball coaching, if there was a method that worked for everybody, all the teams would be doing well, right? But you run into situations. There's different. There's the different mentalities of the team, the different experiences in the team. You need to really look at that and see what is the best way for you to communicate with them. So here we go. We're entering the soft skills. If you want to save money on a project and increase its likelihood of success, this is a major part. So I'm going to show a presentation that I gave to our leadership. Just a little bit of background. There was a lot of change in our division, and people sometimes are they don't like change. So I presented this to help them understand that not all change is bad, and that as leaders, they have to navigate this and help the larger group in general. So this was about 150 people this was given to, and most of them were leaders in some way, whether it was marketing or sales or engineering or ops. So I'm a marathon runner, so I kind of use this experience in that regard. And that's one thing. If you're using examples, I'd say make it real. Do it. Use something that you know. Not only does that help with your own analogy, it also helps them understand you. And that's a kind of the key point too. Is you need to understand them, and they need to understand you. So I compare this to quality medical device developing is not a marathon, it's a sprint. Okay, it takes a well thought out plan. It takes discipline to follow the plan, but to meet the goal, you may need to incorporate multiple options because not everything is under our control. Or something, there's market issues that can change, and for one thing, we don't know everything at the beginning. We don't know exactly if the thought we had or the solution will work out, so you need multiple ways. But the one thing I want to mention, there's nothing slow about a marathon, right? These guys are running fast, right? They're running sub 5-minute miles. So when you think about a marathon, it's not about going slow. It's about making a plan so you can get to the finish line as fast as you can, but reasonable. You don't sprint at the very beginning of a marathon. You're not going to make it. Okay. So contingency plan. I'm just going to go through this a little bit. So last year I ran the Boston Marathon. My goal, that was my stretch goal. I was trying to do a sub 3-hour marathon. If everything worked out well, I was going to run that at Boston. My end date was the Grandma's Marathon. So just like projects, sometimes you have stretch goals and then you have the real deadline, right? Another opportunity came in for since I was at a conference at Edinburgh, there was a marathon. So I stuck that one in there too. So Boston was really hot last year. So after 17 miles, I could tell I wasn't gonna hit a sub 3, so I backed it way off and used it as a training run. This year it was pouring. If you guys, any of you followed that. But, so next, Edinburgh, it was poor timing, and it was very hot and humid. So again, I used it as a training run. I actually walked the first 4 miles of that and then ran it. And there were a lot of people behind me saying, "You can do it, you can do it," because they didn't know that I was just using it as a training run. So then, okay, so it's down to the last one, right? You don't want to change your plans. However, that one's going to be hot too. So the Wednesday before a Saturday marathon, it looked like it was going to be 70 degrees and showers. I'm like, okay, this is not great because I've spent months training. Well, there was a contingency plan. There was a Manitoba marathon the same weekend. So 3 days before the marathon, I signed up for this one and drove to Winnipeg and ran it. And it was 15 degrees cooler and it was ideal conditions. So, I lost a hotel room, etc. There was some cost associated with it, but it was worth it for me. Great weather, and I didn't get quite my sub 3, but I got very close, 3:02:51. So that change, even though it was very late, it made sense to do. So when you look at projects, the key is the rationale of why you make change. And in order to do that successfully, I recommend that you have rationales for everything you do all the way along. Because to make late changes like this, you have to go back to the rationales of why you are where you are today and why it would make sense to change or not to change. I think that's the key on system engineering is the rationale part. People will follow rationale. They don't have to follow you. But if the rationale makes sense, they will. So keep that in mind. So then I led into leadership a little bit and teamwork. Okay, so I finished 20th in this marathon. It's about 600 runners. But I looked like at 3 miles or so to go, there were some people passing me that didn't look like they were marathon runners. Like they weren't super thin. They didn't look like that gait would have lasted 26 miles. Like, what? How can they be beating me? I mean, I've spent months training on this. So those are the question marks. There's 7 of them that beat me. Can you tell by the names how they beat me? The names give you a hint?
Relay team.
Yes, they're relay teams. So you could have a relay team up to 4 runners. So I looked at that. If your goal was to finish 26 miles, those people did it the better way. Right? As a team, you can accomplish so much more. I was out of commission for probably 2 months after that, right? I couldn't run very well because you would burn out. Those guys could probably run the next weekend. So as a team, they accomplished something much better than I could do on my own. So I use that as an example because we have these people that are super skilled engineers, but they don't like to work with other people. I was trying to convey that, work as a team because you're actually going to have less burnout and actually work better as a team. So that was my kind of my talk, and I went into a little bit about marathon, actually relay teams, because I let's see. Well, and then so as a team, just saying you have a team doesn't make it a team. There's a classic example of this. So back in '88, South Korea, there's a box exchange. So the U.S. men assembled the best racing group ever, bar none, for a relay team, right, in the 4x100. So Carl Lewis had the opportunity to become the biggest medal winner in Olympic track history on this team. So all they really had to do was be able to hand off the batons, because they had so much skill compared to everybody else. But they fumbled it. So here's a quote from Carl Lewis afterwards. Look at this. "I feel bad, of course," Lewis said, "that I will not have the opportunity to run the 4x100 relay because they messed it up in a qualification and didn't do the final. I felt confident that our U.S. team would set a world record. We had the greatest group of sprinters ever assembled." The greatest group of individuals versus the greatest team. So again, there was not a lot of team effort on that. They did not practice a lot together on exchanges. They were doing their own thing, and it cost them. So this happens over and over again. So as systems engineers, we have the ability to manage how teams interact, and they'll be, most of the time, they're very. The team is very welcome to have some of that help. So you can set the team attitude. Be a team supporter. Everybody, very rarely does someone not bring value to a team. They bring a different value sometimes, but key is to bring that value and understand their value. Let's see, how many people here have done a strengths finders? That's good. So of all the tools, there's a lot of ways to look at teams. I think that's one really valuable tool because it's a positive, right? You understand kind of the strengths of that person and you build towards that. It's also helpful for you to share what yours are. So then I think it really helps you to interact with people to understand where they're coming from. So again, as team building, I've seen that of value. Our system engineering group did that, and it really helped us understand the strengths that each individual had, and then it looked at gaps. If we had talents that were not existing on the team, when we added people, we kind of looked for that. So be confident and work together as a team that you can find the right options. Not as single engineers, we just still know all the answers. Even as a group, we're going to struggle, but together we'll do a much better job. I'd say be a humble leader. There's the engineers you work with are going to know their space much better than you are going to as a system engineer. You're kind of on that top level, but you're that glue to relate to what they're working on and how it relates to the customer. So really take value in that. You are the independent decision maker. Right? You are not really making anything physically that's going to go into that device. You're helping other people assemble that. So that's a unique position as a technical lead, where people can go to you and talk their case on why they think a certain feature may or may not be in it. And you can assess it. You don't have any baggage of, you shouldn't have any baggage if this is your favorite feature. You need to be open about it, how it really applies to the customer. And you can make that decision with all the information. That's very valuable. Again, understanding all the viewpoints can help the team make decisive decisions with understanding. And be approachable. Kind of look at some tests. How much traffic comes into your office? When there's a problem, are you the first to know about it, or are you the last person to know about it? If you're the last, you need to change something, because it's critical that systems knows about stuff first. You do not want them finding an issue and just sitting in their office trying to solve it themselves, because it might not need solving. That's a lot of times that's the case. They're so deep and they see, oh, there's this issue, I need to solve it. Sometimes it doesn't need to get solved. So what do people talk to you about? Just have that, just kind of take a look at that, see how well that's going. So I recommended having scheduled team communications. So some of my larger projects, I spent a lot of my time on this system development team meeting, or system design team meeting, however you want to describe it. But it eventually had managers in it too. Initially I just had the technical leads, but management wanted to see what was going on, so I invited them. But it was a very open environment, and if you can't get an open environment with your managers there, you need to have another meeting with just the technical leads so that they feel comfortable. Sometimes they don't want to bring up mistakes if their manager's there. That's not the kind of environment you need. You need to just allow them to feel comfortable to be open with it, and you can solve the problem as a group. It was very typical for me to spend 2.5 of my 5 days on this one meeting, on the prep work, on the meeting itself, and then the write-up, especially the write-up after it. I own the meeting minutes because that was critical in my view. That not only did it help me logistically figure out if all the rationales made sense as I wrote it, but then that documentation was there for the whole team I distributed. So again, just some common sense things, but sometimes it's hard to do. Ensuring everyone has respect, or you treat everyone with respect, and you can use these types of meetings with different walkthroughs. One of the issues I've seen is that depending how you write your specs or your requirements, they're conducive for one type of group. So you're the glue. Your requirements have to make sense to the marketing group, and they also have to make sense to engineering. How in the world are you going to do that? So that's why I really say you need to sit down and talk through what this system is going to do, especially to marketing, because a lot of times system specs get a little too complicated for their level, and they lose exactly what the system is trying to do. So take the time to communicate, and that helps keep projects on the right path early. I kind of talked about this a little bit. Get to know your team members, know their backgrounds. I mean, have lunch with them. Not everything has to be work related, because if you know what some of their interests, that can really help sometimes when you have a problem. You don't want to be the person that whenever they see you, it's always an issue. And you'd like to have just walking around where you can chat, you know, without having something going on. Because there have been managers that I've had, the only time you see them on the floor is if there's a major issue. So the people tense up. That's not the type of reaction you want to have when you're walking the floor. So these are a couple examples I've done with teams, just for fun, just to give you some ideas. So we have a Neural Nets basketball NCAA brackets. So I lead that. I think we have 25 people in it now. But we have a traveling trophy, and I write up a daily assessment of how they're doing, and I have a bunch of stats. So they have like career stats on it and everything. So there's been some people that have done it all 25 years. So again, it's just a little bit of a break. It has some friendly banter that relieves some of the stress, I think, on projects. Has anybody ever here done a Ragnar relay by chance? So these are 20 or 200-mile relays that 12 members do. So I'm the captain of our one for Neuro. This is again, this is a great experience. It's really on teamwork, because you can never do 200 miles, or rarely as one person, but you do it as 12, and you're in a van and you hand off basically. You run 3 different legs about 6 hours apart, and so you're rotating through people. It's been almost life-changing for some people because of the effort, because you're only running, you know, at most 2 hours of the, or 3 hours of the time. Most of the time you're supporting others, so you're helping them with water, you're making sure they're good, you're going through logistics. This is a picture of so we just wanted to try it 1 year. It was 5 years ago, and this team has stayed together now for 5 years. This is a picture of us when we did a Ragnar in Hawaii. So the team actually decided to travel together to Hawaii to do one. And this is where their founding, Medtronic's founding father, Earl Bach, and he invited us to go visit him on the island because he lives there. So, so there's some benefits. So think about that too. The interests that your groups have. Another interest that we have is when we do our planning, we do brewery visits. So each planning meeting we have, we go to a different local brewery. There's tons of them in the Twin Cities. So that's kind of a fun thing too, just to, and we'll talk about running, but then we'll talk about work stuff too. So if you're not good at entertainment, have someone to help you that's on the team. So no problem with that. Okay, system engineering. We've been pretty heavy on this side, I think. Build the product right. Right, so you want to build quality products, reduce product costs. So I'm just thinking on a $50 million project, if you could save $2 million, you're probably a hero, right? If your system engineering techniques got you $2 million in savings, that's phenomenal, right? Build the right product. So you want to obtain quality inputs and generate revenue, not trying to save money, but actually generate revenue. Spinal cord stimulation, one point of market share is $25 million. So think about that. You need to look where you need to focus your efforts. So look at your market. So if you're all here, that might be the wrong place to be, because it's really about revenue, right? Unless you're in an environment where that just is not, there's no way to increase your revenue, so then you're looking at cost savings. Because this is, right, this is a project, this is one project and it's done. When you start gaining market share, that's annual. So that gets, that number goes up fast. So, so looking at building the right product, that front end is very key. So having those relationships with the sales force, the marketing group, and their customers, and at least in device, in the device industry, medical device, it's very key when you're visiting that it's a positive outcome. You don't want to have engineers go out there and it causes issues with the sales force or with your customers, because they're not going to invite you back. So many times I've ridden for the day with a sales rep to see what their life is like out in the field, and it's very helpful. But be, like I said, be very humble and listen. So condition number 3, have you heard the customer is always right? Here's the chaotic part. The last customer to give feedback is always right. Have you ever ran into that? So a marketing group that doesn't have a lot of direction, this sometimes happens. You'll get the inputs from the very last customer they talk to. So that just causes quote unquote chaos for us, right? Because we've got our design in place. Now they said you need to have widget X because so-and-so said. So usually it's caused by poor input collection methods, sometimes by changing leadership. And maybe new leadership needed to be changed. Maybe the direction wasn't right, so we have to look at that. But I see a lot of this issue is the design inputs are based on intuition and not information. So we need to help with that to make sure that marketing understands that we're going to do projects and get inputs that are based on information, not intuition. So a lot of my work has been working with marketing. And again, like it's listening, understanding market dynamics, meeting with the customers, see the products that are being used, and really try to get them to use some engineering assessment tools. One example is a pulse of quality. There's Pew matrices. But look at the type of tools that you think would work with your marketing group to get some meat behind what they're trying to assess. And I think that will help them too when they go out and do surveys or other techniques to get that information. And again, always with the rationale behind it. So